Okay, so now we're going to hit the last two objectives of Unit 1, Part 1. This is lesson Unit 1E, Part 2. So box plots are really good for comparing. Actually, when it has a similar scale, the same scale, stacked on top of each other, it's really nice. So we're going to try one here. So baseball has been a popular sport, somewhat, since especially back in the day. But the era from 1900 to 1920 is known as the dead ball era due to teams hitting very few home runs and scoring few runs. The researchers believe that there was a second dead ball era from 1964 to 72. Could this be true? Here are the following box plots display the distribution of home runs hit by Major League Baseball teams in 1968 and 1978. Those are, one from each of the dead ball eras, supposedly. These are also the summary statistics. I love they provided the statistics as well. That's actually really nice. So let's talk about it. So compare the distributions. So we want to talk about shape. So 1968, the shape clearly skewed to the right. It's got an outlier on the right, clearly skewed. 1978, it's not quite as clear. Let's look at the mean and median here just for fun. So 113 for the mean. Median is 110, so it's a little bit bigger. Maybe we say slightly skewed. You might get away with the proxy symmetric. I'm not sure what they're going to say. Be interesting. But it's close. Okay, so let's see. Center, so the median for 1978 is 110, which is much larger than the median for 1968, which is 97. I guess I could use the statistics. I'm trying to look at the graph there. So IQR would be great. Well, they even tell us IQR. It's so much larger for the 1968 is 39, which is larger than the IQR for 1978. Shape, outliers. Outliers in 1968 has an outlier. 1978 does not have an outlier. We can say that definitively. Okay, we want to talk in context, so you want to say those things knowing you're talking about Major League Baseball home runs from different years in Major League Baseball history. So roughly symmetric with one high outlier, but the distribution of home runs hit is approximately symmetric. So they actually said, that's interesting. I really was thinking 1968 was skewed to the right, mainly because of that outlier. So what's the mean and median for 1968? I don't know if they're right on that one. It's 100 approximately to I guess 97. Well, I guess it's only 3 in each of them. You could say mildly skewed to the right, maybe. Probably accept either. Outliers. One high outlier clearly there for 1968. Center, so median's really easy to compare there. And IQR. They just say, the more variability by mentioning the IQR. They're justifying it with the IQR. Actually, this is kind of an interesting one. So, Mr. Starnes they have two AP Stats teachers at the school. Mr. Starnes is in charge of the schedule, so the other teacher is suspecting that maybe he got the better students, like he handpicked them or something. Provides data on cumulative grade point averages of the students in both classes. So here are the grade point averages for all the students in each of those classes. Based on this data, did Mr. Starnes stack his class? Give appropriate graphical and numerical evidence to support your conclusion. So we're going to crunch the numbers on those two guys. Let's see if they do that for us. Oh, this is interesting. Percentiles are one option for comparing relative positions. Okay. So we could do what's called a standardized z-score. So this is new. We've not done this yet. at AP Stats this year. Okay, so oh, they don't have the. I guess they didn't do it. I thought they were gonna. I guess that's your job. You would do that. We'll get to that in a minute, I think. Okay, this one that they're going to do it. This is one I want to look at. Then sorry about that. So competitive gaming is not just a hobby, also become a real profession. Some gamers make more than 100,000 a year. Maybe I need to become a gamer. I tested video games in college. TurboGrafx was the name of the game for me. The League Championship Series team of 5 players against each other. And the game is the League of Legends. 2 ways to measure the value of a player and the amount of damage they cause and the amount of gold they earn. That makes sense. The table shows the mean and standard deviation of damage per minute, DPM, and gold per minute, GPM, for all 41 LCS players in a recent year. So they're probably causing lots of damage and getting lots of gold, I think, if they're good. So was Chime better? Had rates of 182 DPMs and 228 GPMs. Was Chime better at causing damage or at earning gold relative to all LCS players? Justify your answer. Okay, so it's interesting. So what do we need to do? So we need to get z-scores here is what we need to do. So the z-score for DPM, or damage per minute, is the what he got. So this guy had damage per minute of 182. So that's the like the sample there, minus the mean, 477, over the standard deviation of 240. So that gives you a z-score of negative 1.2. Ooh. So I think you want more damage per minute, and he's below average. He's 1.23 standard deviations below the mean. So that's not good. We probably should go over z-scores. So do they have an example here? Let me. Did I skip something? So let me get a sheet of paper here. I can do this here. So let me just stop and do z-scores for a second. So maybe y'all have learned z-scores, but I don't remember talking about it, so I'm not sure about that. So z equals like the sample you got minus the mean over the standard deviation. So so z-score is a measure. It standardizes the score. It kind of so oftentimes we'll use a normal curve a lot with z-scores. So a z-score of 0 means you're right on the mean. And if this is symmetric, it's like a normal curve here. If you're 1 standard deviation above, the z-score measures in standard deviation, or you could be 1 standard deviation below, or 2 above, 2 below, or anything in between, really. So anything time you get over 2 standard deviations in either direction, you're getting pretty extreme. So if you had a z-score of 2.1, so that means you are more than 2 standard deviations above the mean. That's like right there, right? Somewhere a little bit more than 2. So your score, whatever your score is measured, it's above the mean. So it's better than the mean by 2 standard deviations. So that's pretty unusual. You can see that most of the data pieces are going to be within 1 standard deviation, about 68% typically. Within 2 standard deviations, about 95% of the data. So this is getting pretty unusual if it gets out there above 2 or below. Like if you had negative 2.1, if that was a negative 2.1, that would be 2.1 standard deviations below the mean. That'd be extremely low score. So we plug into this formula. Again, it's kind of a z-score formula. And it allows us to compare. I mean, here we're comparing this guy's score, Chime, and he did not rate well against a typical player in damage per minute. So his focus is not on damage per minute. Maybe he's really good at gold getting. I'm not sure. Let's try it. So let's use our calculator to get this. So let's do a fraction in our calculator. So his gold is 228, that's the sample, minus the mean for gold, GPMs, is 365.317, all over the standard deviation for GPMs, which is 83.146. Wow. So he's also behind the times. He's 1.65 standard deviations below the mean, also in gold getting. So this guy is not a pro. He's might be okay. He's below average in both causing damage and earning gold. Because the standardized score of negative 1.23 is actually larger than negative 1.62, he's a little bit, even though he's kind of bad at both, he's a little bit better at causing damage. He's really weak in gold getting. So because, again, if you looked at on a scale, like negative 1.2, so if you got a scale here, you got 0 is the mean. So this is negative 1, negative 2. Negative 1.2 is right there. I think that was the damage. So this is negative 1.2 is the damage per minute. And somewhere around here is the gold per minute. So you can see he's worse off here than he is here because that's further to the left. You want those numbers to be large, so those are quite small. So it's kind of cool. We can compare totally different things using z-scores. So it's actually really helpful. You could use that to compare compare your ACT score to your SAT score, but you have to know the mean of standard deviation. But that's actually published, so you can do that. Okay, that was the lesson. Again, using z-scores is a very effective way of comparing things that don't have the same scale, that are kind of different things. We can compare them with z-scores. So it's really effective way of doing that. That's your lesson for today.